When you mix two dissolved ionic compounds, you can have, as previously seen, where no reaction actually takes place. But when mixing these compounds, it is possible that you would actually form a substance that will not stay in the solution. And what that means is you either form a solid, a liquid, or a gas. Examples where you would see a liquid would be where you form something like water, and really that tends to be the only example where you form a liquid. Forming a gas, you would often be able to tell because a question would actually tell you that a gas is formed, or bubbles would come out of solution, or often a big clue is that you see carbon dioxide as one of your products. When it comes to finding if a solid was formed, there's a little bit more to it than just reading through the question. So what I wanted to do is work through an example of a precipitation reaction so that we can see how you would be able to predict if a solid would form. Up here I have an example where we have sodium chloride reacting with silver nitrate. This, I know immediately, is a double replacement reaction. And the reason that I know it's a double replacement reaction is based on the types of reactants that I have. Because I have two ionic substances, I know this has to be double replacement. And remember what happens in a double replacement is the two positive ions end up switching places with each other. And so on the other side of the equation, what I would get is the Na would now combine with the NO3. When you form these compounds, you have to keep in mind the charges. So sodium has a positive 1 charge. Nitrate has a negative 1 charge. Those balance out, and I just have NaNO3. The other compound that I would end up forming is I would end up forming the Ag combined with the Cl. Now, it is very possible that mixing these two substances doesn't actually react. So we need to check and see if that's actually going to take place. And that's all based around the states. So when we're dealing with a double replacement, our reactants must be aqueous. A double replacement reaction only happens if things are dissolved in water. Then what we want to do is predict what state our products would be in. In order to do this, you're going to need a solubility table. So in your data table package, you probably have something that looks similar to this that says the solubility of common compounds in water. And the way that we use this is we take a look at how the negative and positive ions come together and determine if they would be soluble or insoluble. So with our first example, we have NaNO3. So what I want to do is find my negative ion nitrate, NO3. When it is combined with any positive ion, it will be soluble. That's another way of saying it will be aqueous. So this will actually stay dissolved in the solution. So now let's check AgCl. So AgCl, what we want to do is look at our negative ion, Cl minus, chloride. When it is combined with, so now you go to your positive ion and find Ag, it tells us that it has low solubility. Low solubility is another way of saying that it is going to react and form a solid. This would be called a precipitation reaction, and AgCl would be the precipitate. What you would end up seeing inside of the container, so if this was my beaker and I had my liquid in here and I mix both of my reactants into the solution, you would actually start to see little drops of solid, and chances are it would get very, very cloudy. And if you let it sit for long enough, the AgCl would build up as a solid on the bottom of the container. We call it a precipitation because it falls out of the solution. kind of like snow falling to the ground or rain falling down. Same thing, it's just a solid that is sinking to the bottom of the solution. If you have a double replacement reaction and there is no solid that actually forms in the end, or no liquid, or no gas, there was no reaction. So I think now would be a good time where we actually take a look at an example like that. So in this example, we're going to take LiNO3, so lithium nitrate. It's going to be aqueous because it's going to try and react with potassium bromide, KBr. Since those are the reactants, they're both going to be aqueous. Then, because it's double replacement, we're going to swap our positive ions here. So we're going to take the Li right here, and we're going to take the K right here, and they are going to switch what they are bonded with. And then we want to check those states to see if a reaction would actually take place. So what I'm going to get is LiBr. Now, positive 1 charge, negative 1 charge, that balances out. And then I'm going to get K with NO3. K, NO3. Again, positive 1, negative 1. Now, in order to see if this reaction would actually go forward, we need to check our solubility table. So, bromide with anything that is not lead, silver, mercury, or copper 1+, those are all going to be soluble. And so that means that lithium bromide is dissolved and is aqueous. KNO3, well, KNO3, anything combined with nitrate is soluble. So this is aqueous. What that means is there was no reaction. Nothing actually took place in this situation. Really, all that happened is you poured this into this, and then nothing changed. So your question may be why? Why does nothing actually take place? Well, it's important to understand what that aqueous means. Remember from dissociation that aqueous means the ions have been split apart from each other. So when I write LiNO3, what I'm really saying is Li plus aqueous, NO3 minus aqueous. KBr aqueous is the same as saying K plus is dissolved and Br minus is dissolved. And now if we take a look at what should have formed, if there would have been, let's just take a look at our substances here. So LiBr aqueous is Li positive aqueous, Br negative aqueous, and KNO3, K plus aqueous, NO3 minus aqueous. So now, if we take a look at what actually changed over the course of this reaction, well, Li, NO3, NO3, K, Br, Br. There was literally no change from reactants to products. And that, by definition, means there was no chemical reaction. Ultimately, all that happened in that case is you had two substances mixed together in one container. And because nothing reached a point of saturation, because they are all very soluble substances, they stayed dissolved. The only way a precipitate happens is if one of the substances reaches a saturation point, and those are substances that have low solubility in a solution. So remember, if you need to predict precipitation in a reaction, do your double replacement, predict your products, and check your solubility table to see if any of them have low solubility. Okay? And up next, I'll show you how we can take a look at writing this in some different ways. So, thanks for watching.